Hi everyone, my name is Daria and I'm happy to have Sylve Chevet as the guest for this interview. Sylve is the co-founder and CEO of Hylé, the lean blockchain for provable apps. Sylve's team is part of zero-knowledge movement in the blockchain field. Watch this video to learn more about the zero-knowledge concept and its implementation in consumer-oriented applications. So, Sylve, it's fantastic you joined me for this conversation. Please share some interesting facts about your professional background.
I'm very excited to be here. Thank you very much for the opportunity. I spent my entire career in blockchain. I am slowly making my way further down technically in the blockchain stack. I started out with wallets. I was working at Ledger as a product manager. Then I moved on to building the biggest NFT protocol on Starknet called Brick. Co-created Dojo, a provable game engine built with Cairo. And I'm currently in the lowest possible part of the blockchain stack, which is that we're building Hylé.
Thank you very much. So what is Hylé? What is its mission and vision?
The vision for Hylé is to enable everyone to benefit from the technology of provable applications and specifically of zero-knowledge proofs. So what are these? They were a very, I would say, obscure research topic some 10 years ago. My favorite forum post is one by Satoshi Nakamoto, I think in 2010, talking about what kind of solution they could implement to help scale Bitcoin. And something he said, or they said, is there's this weird part of mathematics called zero-knowledge proofs, which allows you to prove you've done something without revealing the whole thing, which means that it can just be, you can prove something very big and just give a very small proof. If that worked, it would be fantastic for Bitcoin because we could do very complicated things outside of Bitcoin and just verify it on Bitcoin. It doesn't work, so we'll have to make do without it. And the past 10 years in blockchain have made it that the research in zero-knowledge proofs has advanced like tremendously because it's been used as the number one factor to help scale blockchains. And currently, it's only a use case, but what we believe in is that the technology will improve to the point that everyone will be able to use it to build fully trustable applications. And we're designing the blockchain network that is specifically done for this. Zero-knowledge proofs came after blockchains. Blockchains are about 16 years old.
Yeah.
Zero-knowledge proofs, probably, let's say, like 5 to 10 years old. So we're now, what most people are doing is taking zero-knowledge proofs and try to cram them back into blockchains. And what we're doing is that we're designing a decentralized network that is specifically tailored for this type of applications.
Hylé, the lean blockchain. What does it mean? I think that many people know what is lean startup or lean in manufacturing from Toyota and other companies that use this approach. But what is lean concept in the blockchain?
We chose this term because what Hylé does is that it gives you the minimal part that you need from a blockchain in a post ZK world. What does that mean? When blockchain started out, you had Bitcoin, which was a very, very simple network. Bitcoin allowed you to exchange value. That was its only function. You do not have a lot of expressivity on Bitcoin. You can't write very complex programs. It's not designed for this. Then Ethereum came in, and Ethereum is branded as the world computer. And you can build what are called smart contracts. And what are smart contracts? They're programs that are running on this massive decentralized computer that no one owns. That is Ethereum. So Ethereum is doing a lot of things. When you send a transaction to Ethereum, it's like you're giving a list of instructions to the computer, and everyone on the network is going to verify that computation, and that's very expensive. So if you take like all the parts that a computer does, you have the hard drive, and that's storing the data. You have the CPU and the GPU that are doing the computation. You have the RAM that is like very temporary memory. And Ethereum is all of this. It's like a virtualized, a decentralized version of a computer. The issue that you have with this is that you need to, because it's decentralized, you need to have all the little computers that create this giant computer basically go at the same speed. It's like you're trying to run with 1 million people with you, and you're all holding hands. So you can't, maybe you have a sprinter, like maybe there's one person.
It's a bit difficult.
it's very, very hard overall. You need to coordinate. That's what consensus is about. Consensus is, okay, there's a tree in front of us. We're going to move this way, and then you're going to weave back this way. So it's already complicated to synchronize all of this. And one of the issues that you have with synchronizing this is you can only go as fast as the slowest runner. So maybe you have a kid with you, and the kid is like very motivated to be part of the race, but they're 6 years old and you're 7 foot tall, and you have to slow your pace so you can run with the kid.
Yeah.
And that's currently how blockchain infrastructure is built out. You need to make sure that anyone can join the network and perform the computation. When people stumble upon the idea of blockchain, usually what they think, generally programmers or developers, they have the very simple yet normal idea of saying, why don't you just have bigger blocks? Why don't you just use bigger computers? And that would be similar to saying, why don't you just have only fast sprinters? And that's true. But the issue if you only have fast sprinters is no one can get in the network. No one can participate in it.
It's not inclusive.
Exactly. So what we do is that we limit the network speed to the slowest runner, which is so there's a specification for a type of computer, and that computer is, let's say, a high-end consumer laptop. What we're now able to do with zero-knowledge proofs is benefit from the speed of the fastest runner and ensure that the slowest runner is able to participate in the consensus. And the way you do this is by having the very powerful computers do all the hard work themselves. So you ask them like, okay, coordinate between yourselves and just go super fast. And then you have the slower computer verify the work that the very fast computers have done. And that's why you use zero-knowledge proofs. So that was a very long metaphor to explain what Hylé does. Hylé is a blockchain that takes to heart to be designed around this specification that is allowed by zero-knowledge proofs. So what Hylé does is it will sequence transactions. So we'll just say, okay, this one came before this one came before this one. That's like very light, what is called data availability. And then Hylé will verify the proofs that have been done by the very fast runners, by the very, very powerful provers and computers. So rather than currently on Ethereum, the way you would do it is, okay, here's a list of instructions, and then you have the million people holding their hands and running together to do the computation. The way it will work on Hylé is you will say, okay, here's what I'm about to do. Register this because I'm going to compute it and then give you the proof. And then later on, you come back with the proof and you tell Hylé, okay, so this is what I've done, and here's the proof. Update. So it's a very, when we say lean, when we come back to the explanation of the computer, you remove a lot of parts of the computer. That computer does not have a CPU anymore. The CPU is outside. It doesn't have a hard drive anymore. That hard drive is outside. What you have is a verification engine for zero-knowledge proofs that allow you to trust stuff that has been done on hard drives and GPUs and CPUs outside of the blockchain. So what does this give you? It gives you a lot of flexibility as a developer, because maybe you want to use a certain type of computer, or maybe you want to not run everything that you're doing fully on the blockchain. You want to anonymize parts of it. We give you that flexibility. Second, it means that the network is very simple. We drastically reduce what Hylé does. To give an example, most blockchains have what is called an execution environment. So that's what, when you write a smart contract on Ethereum, you use Solidity. And that's the language that you give to the Ethereum machine. You write your code in Solidity, then you give it to the Ethereum machine. We support, at the same time, no programming language, but we also support all programming languages. We support all languages that can generate a proof. So rather
you mean like Web 2 programming languages like Python or old blockchain languages?
We call them provable languages, which are languages from which you can generate a proof. So you have languages that are specialized for this, like Cairo and Noir, but you also have very fantastic tools called ZKVMs, zero-knowledge virtual machines, that allow you to use theoretically any type of programming language, most specifically Rust. And you can just build your application using Rust, not even have to think about ZK or whatever, and then generate the proof with the system. And Hylé ships natively the verification for such systems. So you don't need to learn a new programming language. You can benefit from the affordances that the ZKVMs give you. Just focus on like the parts that make sense for you.
Thank you very much for great explanation. Why do ZK proofs so attractive to blockchain community and to investors? Do you have an answer?
I think it's a fun time to be a cryptographer because we have someone on the Hylé team who comes from like a math background, and they've done cryptography maybe 20 years ago. I hope it's 20 years ago, otherwise they're gonna
Oh my God.
make fun of me. And what they were working on was emails, because if you wanted to work in cryptography, that was the one thing that you were doing. Or you would be working in banking or smart cards or the defense industry and passports. When we talk about crypto, people usually think cryptocurrencies, but crypto comes from cryptography.
Cryptography, yeah.
And one of the best things that blockchain has done is it has funded the research and has allowed the development of a lot of cryptographic tools that were very, let's say, theoretical 20 years ago. So that's ZK, MPC, FHE, all the three acronyms that anyone understands. Why is ZK particularly interesting? The way I like to think, in the blockchain context specifically, the way I like to think about it is like the very early steam engines. When we think about steam engines, we think about steamboats, we think about trains. But the very first usage that we had for the steam engine were to pump water out of the coal mines. That was at the end of the 19th century, end of the 18th century. That's very, very old. And why were we using them for that? And why didn't we just start with the steamboats? Because that just seems like a very natural thing to do. You have a great source of power with coal, and that allows you to move things very efficiently, efficiently at the time. The reason we started with the coal mines is because these engines were so inefficient. They were just very bad. They consumed so much coal. They were just not very great. And the only area where we could use them and where it made economic sense to use them was next to their own power source in the coal mines. So you would put the steam engine that used coal next to the coal mine. And that meant that you could pump water out and you could get more coal. So the cost of coal decreased. And that meant that you could use the steam engine elsewhere. And that also meant that the steam engine got better. And then we applied it to a second industry, which is the textile industry. And because you just needed a machine that could generate like a circular motion over and over and over. And then you applied it to the steam engine, to steamboats and trains. But it came in that order. Currently, the first usage that we had for zero-knowledge proofs was to help speed up blockchains. Why is that? If you read the first papers that you have for zero-knowledge proofs, on that point specifically, I had a funny interaction on Twitter one day with Elie Ben Sasson, the inventor of Starks and co-founder of Starkware. I asked, has anyone seen usage, like real-world usage of ZK at scale outside of blockchain? And he was the first answer and just laconically said, no.
No, just blockchain, yeah.
But when you think about it, you can find many, many usage for zero-knowledge proofs. You can think of, it would be a way, for instance, for a bank to prove that they actually have the funds that they tell you that they have. It could be a way for you to prove that you're a citizen of a certain country without going through a very, very lengthy KYC process.
Yeah.
It tremendously lowers the cost of trust. But the first thing that we actually used it in was the first niche that desperately needed it, and that was blockchain. Because, as we explained it before, it's very expensive to do things on the blockchain, and it goes very slowly. So why don't we just use very fast computers for this, generate the proof of their work, then have the slower computer verify that? That was the first use. But obviously, it's going to generalize to a lot more than just blockchain. It's just the canary in the coal mine, to continue the metaphor.
So, Sylve, how does Hylé leverage ZK better than other companies?
Let's first talk about how zero-knowledge proof works and how you use them currently. A zero-knowledge proof system is comprised of two things. You have the prover and you have the verifier. So if I have to give an analogy, that would be someone is taking the test and someone is checking the test. And the analogy works quite well, because if I want to make sure that you know something about math, I don't have to ask you millions of questions. I don't have to ask you 10. And that's a subset of the knowledge that you have. So how do you verify these proofs? You have companies that are full of researchers and cryptographers that are building these zero-knowledge proof systems. Starkware, Scroll, ZKsync, Succinct, RiskZero, there are plenty of them. And they're all very, very good at their job. The question now is, let's say like one computer wants to prove to another computer something. So the first computer, let's say we want to both prove something. I want to prove to you that I know something. So my computer is going to, we agree on a proof system. My computer is going to generate a proof. That's the prover. I send the proof to you, and you use the other part that's called the verifier to verify that proof. Simple. How does this happen on the blockchain? Well, the blockchain, usually, let's take an example like Ethereum. The blockchain is a computer. So the prover, let's say I want to prove what you want to do now is I'm the computer and you're the blockchain. I want to prove something to you. So we need to agree on a proof system. And then we both need to have a prover. I need to have a prover, and then you need to have a verifier. And that means that we need to have a verifier running as a smart contract on the blockchain. And so in the context of Ethereum, how does that look like? It means that you need to write a verifier in the programming language that the blockchain understands. So that means that you need to run a verifier in Solidity, basically. And the very funny thing is that when you look at how blockchain is architectured and how the Ethereum virtual machine, which is the Ethereum computer, is designed, it's like it was basically made on purpose to be ZK unfriendly. There are a lot of operations that are very, very costly to do in the ZK world. An example are something called hash functions, which are band-aids that are used everywhere. The hash function used on the EVM is very, very, very stark and ZK unfriendly. So you need to have systems that are very ZK friendly, and that's quite typical. So, and that's just for the setup. Then when I need to verify that proof, I'm going to need to send a transaction on the blockchain. And that also has a cost. It goes from about, let's say, 260,000 gas, which I don't even remember what's the cost in dollars, but let's take it anywhere between $10 to $30 for a single proof, and that's for the smallest proof system, up to millions of gas. I think for a Stark, like Starkware, Starknet Starks, it's like 4 to 5 million in gas. How do we do better than this? We specialize in doing one thing really, really well, which is verifying these proofs. So rather than have an execution environment on which you can have everything, we only have one type of function available on Hylé, which is to verify those proofs. So that allows us to give another comparison. That would be your compute. You have specialized chips that do one thing super well for AI, for graphics, that are called graphics card, for instance. Hylé is a graphics card for proofs. So the network is running not the Solidity contract on top of the EVM, etc., etc. We are running the native verifiers, basically the same one that you were running in my first example on your computer, which means that like there's a 1000x improvement just based out of this, just simply. Second improvement that we do is more on the design side for applications. Currently, we try to put a lot of things on the blockchain. Basically, we try to put as much things as possible on the blockchain. Our vision as a company is that in the future, you will be minimally yet sufficiently on-chain. Currently, we're just trying to put everything on the blockchain, and it may not make a lot of sense. So that's why we talk about provable applications. Provable application means that they can generate proofs, but it doesn't mean that every single transaction that you're about to do needs to be a proof that is verified somewhere. If I have to give an example, that would be video games. Video games on the blockchain, like people have tried to build video games on the blockchain, and they're very difficult. It works for, let's say, slower paced game, but if you're playing something like a shooter game that runs
Yeah,
very, very
yeah, yeah,
fast,
yeah.
it's going to be very difficult.
Yeah.
So what we advise there in terms of design, that's what ZK gives you. It doesn't only give you scaling and anonymity, it also gives you flexibility, because it means that you can just have a system that runs off-chain in a very centralized, and you're okay with this trade-off environment, but you're still able at any point in time to generate a proof, like a checkpoint of what has happened in the game, and send that on Hylé. So these are the two ways that we optimize for proofs. First is just building a network that is specifically amenable to this. And second, build a design system for applications that is more flexible than just, just run everything on the blockchain. Maybe a last technical thing that we do, generating proofs has an overhead versus just running the computation. It's slower overall to prove something rather than just execute the code. And that can take a lot of time. For some types of proofs that are very big to compute, it can take hours. That is diminishing as research improves, but there's always going to be an overhead versus just computation. So the problem that you would have in the game example and the FPS example that we were talking about is, say, if you move and then you need to generate a proof for this, that means you need to generate a proof like all the time. And that's very, very, very costly. So the way that we optimize for this is we do something called delayed proving. Delayed proving means that you're just sending transactions on Hylé that are not proved, but provable. That means that Hylé is going to timestamp them. The analogy that I can give you there is like a restaurant. You book a table and then you come in. And that's what we do here. So Hylé orders your transactions, and then you can take more time to prove it and settle it to verify it on Hylé. So that means that you have like instant, what is called finality, like you know that something is going to get verified, and then the proof comes in. Finally, maybe, sorry, I'm just going a bit longer there.
No, that's great.
Because we run these proof systems natively, we have what we call native proof composition. So our first builder on Hylé, Matteo, who's a very talented ZK dev, built a game where you play chess via email. So we both play chess via email. I sent you like knight to e4, etc., etc. Then you win. We're going to call a referee like by email, and the referee is going to generate a zero-knowledge proof, two zero-knowledge proofs, two different ones. First of all, a proof that your email address was the one who won. That's using something called ZK email. That's a specific system. Then it's going to use a ZK VM called RiskZero to generate a proof that you have actually won. In a normal setup, what you would need to do to verify this on a blockchain is you need to put the first proof inside the second proof, or the second proof inside the proof. So you would need to prove RiskZero inside ZK email, or ZK email inside RiskZero. That is called recursion. And that is quite costly because it's like matryoshka dolls. So you need to like put proofs inside proofs, and it's quite difficult and very expensive to do and to compute. The way we do this is by not doing this. You would just send the two proofs on Hylé, and each proof is referencing the other. So you're just going to say, okay, you tell Hylé, okay, here are my two proofs, my two transactions. Now here are the proofs, and verify that this one is okay, verify that this one is okay, and you atomically verify both of them at the same time. I'm not going to go into too much detail, but what this gives you is that you can use any proof system that you want without having to think about recursion or how they work. We abstract that complexity away completely.
So what kind of industries can use zero-knowledge proofs by Hylé?
It's a very good question. Some of the examples that I really love in what people are doing with zero-knowledge proofs are around identity, for example. You have projects such as Proof of Passports, ZK Passport, and Ocelot, who are using the data that is signed on your passport to emit statements and proofs out of it. So there are a lot of discussions in the European Union about gating content to certain websites to minors. And that's quite difficult to do, because how do I prove who I am, how old I am? That means you need to do it through a whole KYC process. And that's costly. Not only is it privacy invasive, but it's also quite costly. That means that websites need to pay these costly KYC services. What ZK gives you is a lowering of the cost of trust by embedding it in mathematics. So it's like the marginal cost of trust goes to zero versus it used to cost maybe, I don't know, maybe like $3, $5 for
Mhm.
any industry that would benefit from higher oversight or auditing can now do it for pennies on the dollar with zero knowledge proofs. So think about, I like the example of FTX there, because you have the founder of FTX going up to Congress and testifying that what we're doing at FTX is, and what the blockchain industry is doing is nothing like what happened in 2008, where you had these shady deals and no one knew what was going on.
Mm-hmm.
And in the end, well, they had the back door. What you could have, one way that we try to tackle this is by telling these guys, that the example I gave earlier, go on the blockchain. But the switching costs are just so high. They're very, very high for businesses, and they're just so high for users that they don't do it. There's, compared to the amount of people on the internet, it's just a tiny drop in the ocean, the number of people on the blockchain. It's very,
Mm-hmm.
very low. So what they could do is continue to operate in a centralized fashion, because I maybe get flamed for this, but I quite like that my bank is regulated. That's something that I trust. That's what most people trust. I like having the option of having cryptocurrency at the same time, but I like having my bank. What I would love, though, is when I connect to my banking dashboard, they show me that I have 100 euros on my bank account. How am I sure that I actually have $100 there? What could be done is actually have the banking system operate as a provable program. So any new operation changes the state of the application, a bit like a blockchain, and that could be used to generate a proof of validity of the operations that they're doing.
Mm-hmm.
So the way it's exactly like auditing a smart contract. You would have the bank create the code, have it audited, and then all the users could have the guarantee even without seeing the code. That's the brilliant part of zero knowledge proofs.
Mm-hmm.
So you could have guarantees that the bank is operating the exact piece of software that has been audited. And that's great, because that would avoid the situation that you had with FTX, where they were swearing that they were running the correct piece of code, but you had no oversight. You had no way to verify this as a user.
Yeah. Don't trust, verify.
Exactly. And for the blockchain, that works. That's built in, because everything is visible. But there's just, even without talking about switching costs and everything else, not everything can operate in full transparency. There are things that benefit from being private. And these things just can't natively run on the blockchain. That's why I'm also quite excited about privacy networks and privacy blockchains, such as Aztec or Penumbra. But I do think that Hylé has a great role to play there.
Thank you. I know that Hylé joined zkBoost Consortium. So what is it, and why did you decide to join? And is it about development, collaboration, or like what the idea of this zkBoost Consortium?
Generating proofs is not an easy business, and that is something that will be offloaded to specialized companies, hardware providers. The good thing is that thanks to zero knowledge proofs, that's the stuff we're talking about with integrity, you can trust that these provers are doing the right work. You can have centralized proving with decentralized verification, and that's what Hylé does. So we can offload a lot of the proving work to these specialized actors and agents, such as the proven services, the proven markets, the proven networks. Hylé will tremendously benefit from this. And we need these folks to exist. The analogy for Ethereum would be, you have block builders. They're not like part of the protocol, but you have people outside of the network that are synchronized into building like things very, very efficiently. It's going to be quite the same thing for proving. So on Hylé, for instance, people are going to broadcast a lot of provable transactions that will need to be proved. So we need this sort of system, which is zkBoost is basically a standardized API for these proofs, so that we can very easily just offload computation somewhere else. So that and it's it's beneficial for all actors in the ecosystem, because if the proof of services and proof networks don't agree on how to receive these proofs, it's going to be very difficult to offload to anyone in particular. You need standards, and standards make things scale a lot easier.
So it's like the community where you try to share like your some tasks between the projects, and like you do better this, you do better this, and then you can like collaborate on some
It's
points.
more like standardization work. For example, email addresses are a standard, and early internet companies had to sit down and agree that, okay, it's going to be this weird little sign called an dot something, and that's how we're going to agree that these things are going to be formatted. It's a bit the same, but for proofs. How are these things going to be formatted? What type of proofs? Where does the proof thing go in the payload? What's the size limit? These sorts of things.
I know that you have raised 3.4 million from different venture funds like Framework Ventures, Cherry Crypto, Fabric, Starkware, and many other foundations and VC funds. What are your priorities in spending these investments? Will you buy Lambos, or maybe you want to scale the team? Like what's the idea and where you can spend this money?
Most of the team is based out of Paris, so we would not have much of a use for a Lamborghini, maybe an electric bike. The roads are just too narrow for this in the city. We shipped a first version, a test version of Hylé, using a toolbox code called the Cosmos SDK that allowed us to iterate very quickly on the needs that we had. We built application ourselves to test out. The first application that we built was following the principles that we talked about do the hot thing outside of the network and verify it on the network. We realized there were a lot of shortcomings in using that toolkit. So we're now focusing on building the blockchain from scratch. So we're building our own nodes, we're building our own client, we're developing the consensus of the network. And our objective is by the end of 2024, we will have a version of Hylé that is testable by developers who want to build provable applications.
Let's talk about your branding. I really like it, and it looks so French, so authentic, so attractive. Who was responsible for branding, and why you use trains as the main visual idea?
When we set out to build Hylé, my co-founder and myself have decided to optimize for, I'm going to say, motivation and interest. We both had an interest in blockchain. We both have an interest in, it sounds corny, like making the world a better place. And specifically in zero-knowledge proofs. We were exposed to that technology with our early days on Starknet, and we just fell in love with it. That's why we set out to build something that is perfectly amenable to that. Part of this course of building an organization and a project that's going to outlast its inception, Hylé the network has to outlast Hylé the company, is making sure that we're in the best position to do this. This is why we have made the choice of having a team that is mostly on site in Paris, because that's how we like to work, and that's how we like to foster innovation. So the idea for this branding came in that same vein of what do we like, what resonates with us. And my co-founder and myself has always been a big fan of a very weird niche of aesthetic called Giscard punk. Giscard is a former French president, and there's a tiny subreddit and a part of the internet that is very dedicated to finding things and images that resonate with that era, which is like 70s, 80s in France. So we love to think about, and that conveys a lot of images around, it's orange, there are trains, there's concrete, there's nuclear power, there's Minitel, which was the French version of the internet back in the day. So we love to think about this. We set out to build a brand around something that looked like us, something that could be authentic, something that we can show to the world, is something that's different than the usual shades of gradients that you see in blockchain. So you're going to see a lot of things that, like a lot of buildings, a lot of people, because we believe that technology should serve people rather than like very abstract concepts. And we just wanted to build something that resonated with us.
It looks very authentic, and you're standing out of the crowd because everyone do this black or blue or some mint colors, like tech colors, and you have this red orange, so very bright and very easy to remember. So it's really cool, and I think that it was super successful decision to make it in this way. What can you recommend to people who are interested in zero knowledge concept and where they should start learning, or like what can you recommend to read, to listen to?
First of all, is Daria's podcast, obviously. Second would be the Zero Knowledge podcast by Anna Rose and the team. It's a great way to get exposed to that content and to the people working in the ecosystem. I think David Wong's is a very good cryptographer and a great communicator. He's doing some sessions online on YouTube about anatomy of a snark. How does it all work? If you want to really deep dive into the inner workings, I think that will be the best resource that you can find. Maybe the best thing that I can advise is if you're a non-technical person, it can be very daunting to approach this ecosystem. It could be you can feel non-welcome if you don't have a PhD in math or even masters.
Yeah, that's true.
I would say that it's a very small ecosystem. There's just so few people that are working in it, and it's something we talked about with Matteo, the builder on Hylé, who was building his chess game and told me, this is not like it's just a toy example. It doesn't amount to much. But what I was telling him is just no one's doing it. There's just no one has built that. And maybe you think that it's not great, but if you just, in absolute terms, so if you just compare to everything that has been done, there's so few examples of applications that are actually being built. It's great to start with a very low-level programming language to understand where like memory works, etc., etc. But it's not necessary, let's say. You can just start tinkering with it. And that's why I really love SP1 and RiskZero, because they are tools that allow you to get on with ZK without even learning a new language. You can just use Rust to tall order because it's still a hard language. You can use normal programming languages to build your application and toy with it. And that's why like Matteo used a ZKVM for the project, because rather than build circuits himself, etc., it was, I can just use a Rust library that is already well used and has a lot of stars on GitHub and put it into a ZKVM. We're in a state of ZK where we're slowly but surely exiting the lab and entering the hackathon phase, where you can actually give it to engineers and hackers and tinkerers to think about more use cases.
So guys, if you're interested in ZK, you know what to do now. Sylve, thank you very much for your time, for your expertise, and it's super, super cool and super helpful to everyone who are interested in zero knowledge concept, cryptography, and everything related.